Homework 1.5, Quadratic Equations, Video 4, homework assignment due Saturday, May 16th, 2020. So that I don't forget, after this video, you should try homework 1.5, questions 5, 6, 7, and 8. Solving using square roots part 2. Again, just a reminder, you should only do this when there's just one x term. Otherwise, there's too many x's, and one of them gets trapped into the square root, which you'll see at the beginning of the next video. But I digress. Let's take a look at these two. Solve x plus 7 quantity squared equals negative 16, and solve 3x plus 1 quantity squared equals 20. If you'll notice on both of these, the square is already isolated, so I don't have to do anything prior to square rooting both sides. But let's think about the problems that are about to occur. If I square root both sides of this for the purpose of canceling the square, I'm going to take the square root of a negative number. Welcome to imaginary and complex numbers. On this one, if I square root both sides, I'm not going to get an imaginary number, but I have the square root of 20, which is not a perfect square. So I'm going to have to break it down. At the end of the video, I said that they're not all this straightforward, and the truth is they are. You just have to be careful when you get to the end, because your square root may require some delicate handling to simplify. So let's start with this one. I've already erased the steps, but remember the first one was, if necessary, isolate the square. There is nothing outside of the square over here, so I can jump right in and square root both sides. So if we square root x plus 7 squared and square root the negative 16, on the left side we cancel the square and get x plus 7, and on the right side the square root of, well, the square root of 16 is 4, but what's the square root of negative 16? 4i. Remember, if you want to, you can separate the negative 16 into 16 times negative 1 and square root each half separately. But hopefully, if you've done the first homework assignment, you realize that you don't have to do all that. When you square root a negative number, just do what you normally do and stick an I on the answer. Oops, I forgot something. What did I forget? On the right side, the plus minus. We're not done, it doesn't say x equals. But I do want to comment about the third step that I said in the how to solve these. The third step was, if necessary, or if you're not finished solving, then you need to split into two equations and solve each one separately. I could do that here. I could write x plus 7 equals 4i, and x plus 7 equals negative 4i. But one thing that you'll pick up on really quickly is when you square root over here, unless it's an integer, a positive or negative whole number, you really don't need to do this split, because watch what happens next. To finish solving this one, I would subtract 7 from both sides to cancel this plus 7 on the x. And on the right side, I would get 4i minus 7, which are not like terms, so I can't combine them. I will get a complex number, and as standard form dictates, you should write the real part first, the negative 7, and the imaginary part second, positive 4i. That's the complete answer. And if I do the same thing over here, I'll get the exact same answer except negative 7 minus 4i. I can't combine them because they're not like terms. And what's the only difference in the two answers? One has a plus in the middle, one has a minus in the middle. So you could write these two answers as negative 7 plus or minus 4i. Well, I could have gotten there real fast if I had just subtracted 7 from both sides up here. So when should you split a plus minus and when shouldn't you? The answer is when the numbers over here change after subsequent moves. For example, if this were plus or minus 4 without an I, then subtracting a 7, yeah, those numbers would change. If this were 4, then this would be negative 3 and this would be negative 11, and I would have gotten two totally different answers. But if whatever you get over here is not like terms with what's on the left, then you're not going to change it at all. You'll just pile stuff up on it. So there's no need to separate. You can always separate, it's never wrong. But if this, in terms of like terms, is different than that, there's really no need to separate because they can't be combined anyway. Same thing over here. Even though there's no i's, watch what happens when I break out the square root. Square root of 3x plus 1 squared equals the square root of 20. Cancel the square, bring in the plus minus. We have a different issue over here. It's not the fact that it's negative, because it isn't. It's the fact that it's a 20, which I can break into the square root of 4 and the square root of 5. Excuse me, I'm about to sneeze. I'm in a room by myself. Boy, that sneeze felt good to get out without covering. Allergies, by the way. It's not COVID-19. Let's get back to the problem. The square root of 20 I can break off into the square root of 4 and the square root of 5. The square root of 4, of course, is 2. I don't know the square root of 5. So think about whether or not we should split this into two equations. The next move I'm going to do from both sides is subtract 1. These are not like terms. Like terms means same letters, same powers, but it goes beyond that. When you have radicals that are unfinished, then you can have what are called like radicals. For example, just a side note, if I had square root of 5 plus 2 square root of 5, those are called like radicals, or basically like terms. There's an implied 1 here. 1 of these plus 2 of these equals 3 of these. But that's not going to happen here, because when I subtract 1 from both sides, this has a square root of 5, this doesn't. They are not like terms. I cannot combine them. So what can I do? The same thing I did here. Just put them next to each other. So I got 3x over here. And which order should I put them in? Well, if you have a plus minus lurking around, you should always kind of stick it in the middle. So we'll stick the negative 1 first, and the plus minus 2 square root of 5 at the end. And now I can divide by 3. Or rather, I should say, try to divide by 3. Over here, I couldn't finish the addition and subtraction problem, so what makes you think I could finish the division problem? And I would have gotten the same 2 answers if I had separated into 2 problems. One of them would have just had a plus, one of them would have had a minus. It's a learnable skill, but there's a time you can quickly discern when splitting a plus minus is a good idea and not a good idea. In a nutshell, if the number on the plus minus, or the number after the plus minus, is going to change as a consequence of future moves, split it. But if it's not, then don't split it. Before I wrap up this section, I do want to show you one more type of answer that we can simplify. Actually, I won't. I was going to say, what about reducing this fraction, but nothing about it even suggests it's reducible. Remember, though, that if you see something like this that's reducible, you can split it into 2 fractions and reduce them separately, even if the thing between the 2 fractions is a plus minus. And don't forget, in the homework 1.5, you should try questions 5, 6, 7, and 8 at this point.